the flyback pulses
Dr. Elie, Spencer.
for energy.
Dr. Elie, Spencer. Since you're here, can you say
Like,
something before? Dr. Elie is saying that you cannot be able to generate more electricity from, like, during the switching of MOSFETs, yeah, you want to be able to generate more current or more voltage.
uh, no, it sounded like I agree with everything he's saying. The flyback voltage doesn't generate excess power.
All right, I agree
And
with you. You're right.
yeah, there's no individual component in the system that we're building that produces the excess electricity. It's a combination of all of the components together into a whole system that produces
Yeah.
excess electricity. And again, that's in the battery's chemistry. And we're just going off of that's kind of Tom Bearden's take on it. The stuff I'm saying in my videos is based on the physicist Tom Bearden, who's passed away now, and he wrote his thesis on Bendini systems and how it's working.
Okay. Have you take a look at the famous paper I was talking about, the Bedini monopole group
Um,
3 paper?
Maybe a little, but just based off what you're saying, Dr. Eli, I agree, especially like measurements, you definitely need to measure. Like we're planning on measuring the work done, the actual work we've completed, and then also the potential energy in the batteries. We're not measuring. We will measure the voltage and the amperage in and out, but like that's that's not where you're going. That's not definitive. You need to measure the potential energy within the system and the amount of work done. And eventually, if you can do enough work, there's going to be such a discrepancy between it that it's definitive, and people will see that it's overproducing energy.
Yeah. Because I disagree with this paper. They try to make measurements uh, of the, for example, the charging the battery, and they make measurements of the voltage at the beginning, the voltage at the
Yeah.
end of the charge, and the current. And I know, but because I teach a little bit of electrochemistry, I know that
Um,
the voltage versus current of a battery is not linear. You cannot make this kind of approximation. You have to record properly. If you, I think in this paper they try to explain that they want to measure the classical energy, because they are talking like you about another form of energy. They are talking about the classical form of energy that the Bedini system, the monopole Bedini, uh, capture and enter into the battery. So they use a classical amperemeter, voltmeter, but the method is absolutely wrong. You are not allowed to just make two measurements. One of the current, we don't know, is a medium current of the RMS current, and make some computation. They provide for you a kind of calculator. You enter a voltage, current, time, and you got the energy. And the worst thing I have seen is how they measure, because according to the system and your system, this classical energy is, let's say, 100. But when you use the battery number 2 to capture work on a load, you expect to have more than 100%. Okay, so you need to carefully measure the work done in load, and they propose in this paper a simple resistor or a lamp, which is roughly the same, and they make measurements of the voltage before the discharge. No problem for me. They connected the load, measure the current. Nobody knows which kind of current is this. Is this a medium, the constant current? Okay. And after they disconnect the load and measure the voltage of the battery after the discharge phase, but
yeah.
disconnected from the load. For me, it's not correct. If you want to measure exactly the work, it seems that you are agree with me. You want to measure first the work that Bedini system introduced inside the battery in the classical way, because we are not able to measure other kind of system. And
Well,
after, if the energy inside the battery with your system has increased compared to the classical energy that you introduced in the battery, you want to measure the work that you can extract from the battery using a load. And the method they pretend to use is wrong.
But I
I
think he
no.
said he said that he said that he was going to measure Spencer.
Sorry, say that again.
You say that you're going to measure along the way the work done to know if what you're
Correct.
getting
Yeah,
out.
we're gonna produce traditional E&M, traditional electron flow in our generator coils, and then we'll put a load on that and measure that amount of work. So that gives us an output from the shaft. We're going to transfer the excess mechanical energy from the shaft and turn it back into electrical energy that we can measure.
You
But
are not using both batteries in
we're
this.
using both batteries. It's just the objective of the both batteries is to maintain. We're not going to draw excess electricity too much directly from the batteries. We're going to just use that to self-run and keep the machine powered and power some electronics.
Okay,
And
okay,
then
no problem for
we're
me.
instead of
Yeah, so you use the
yeah.
first battery like in the Bellini classical
Oh no,
system.
that's key. Yeah, that's key. And then we flip flop between the batteries every 3, 4, 5 minutes. And I guess the main thing with our machine is that we're not using BJT transistors. We're using N-channel MOSFETs, silicon carbide components. So they're extremely
Yeah,
fast.
extremely efficient. Yeah, I know.
Silicon carbide
Yeah,
diodes. So like the on time for our switching is like 12.5 nanoseconds, and then the off switch, which is really critical, is 1.5 nanoseconds. So it's
1.5 nanosecond. Yeah.
yeah.
But did you agree with me that when
Yeah.
you switch, when I have the bench here, when you switch on with your MOSFET, when you switch on let's say 1 amp of current inside the coil, and when you switch off and discharge the coil into a classical load, you will not get more energy in the load than the energy that you put inside the coil.
Yeah, I agree with the Bendini system for sure. Yeah, just
Yeah, but the Bellini
regular
system, I
coil.
agree with you. The Bellini system is a little bit different because you have the motion of the magnet and something like this. But someone,
Yeah,
I made a comment, and someone explained that what I was talking about Bedini, about block wall opening, was wrong. But it was written in the famous paper, Bedini Monopole. Nobody knows exactly how the system is supposed to be working because there is you're supposed to have excess of energy, but if you read carefully the paper, you will see that they explain that sometimes you got under unity, sometimes over unity, depends on the weather, on the moon cycle, and something like that.
yeah, I've heard
It's
that
not clear
too.
what they
No,
are
I've heard that
doing.
too, and like I think that's more for just like a regular Bedini motor at 12 volts. The lower voltage ones,
Yeah.
like they can go over unity, but they're not going to be self-running, so they're harder to measure, right? You just got the work done, and eventually they run out, and sometimes they work, and sometimes they don't. I think
Yeah,
that
it's
issues.
supposed to be working. I can agree that the Bellini is nicely, the motor is nicely designed and it can run by itself as long as you put a battery and the shaft will accelerate, everything will be right. The main problem in this paper is the measurements of the classical energy inside the battery number two and the work that can be extracted from the battery number two after disconnecting the battery from the Bellini system. And I completely disagree with their way to compute the energy coming in the battery and the energy coming out of the battery. But in your system, you are using two batteries, if I
2 battery banks. Yeah, we've got 10 batteries on either battery bank, so we're going to go up to 120 volts.
okay. So you are you using like they are pretending? Are you using a system to measure the amount of energy that your system is uh, capturing from the space or something like that, from the vacuum inside the battery, and then disconnect the battery and use the battery to work, to have some kind of work.
Well, we're just going to keep the whole system running and do excess work with it, and then measure real time how much energy is in each battery bank. And
Ah,
eventually,
okay, okay.
you would, if you
How
know how
can you?
much potential energy. Well, say for example, there's just for example, there's 1,000 kilowatt hours of energy in each battery bank
Yeah.
available.
How do
If,
you know the
if we
status?
did,
How do you know the status of the battery?
well, we've got I forget the model number, but it's a resistive load that you can measure and put
Okay.
on there in amp hours.
So
But
you submit your battery to a resistive load, and you record for a small amount of time voltage
yeah, and
and
that'll tell you the
current.
potential energy in there. But there's also another way to negate even having to do that, right? If you've got 1,000 whatever, you've got 1,000 kilowatt hours in your system. If I do 2,000 hours of work, of kilowatt hours work, then you already know you're over unity if it's still running, right? That's another way to go about it. If you do more work than the potential energy is in the system available, then it's obvious, and it's still running, then it's obvious that you've got over unity. We're going to do both.
How can you measure the energy of the battery without submitting the battery to a load? You cannot.
I'm not saying you can't. I'm just saying that you would know there's other ways of knowing that there's over unity being produced. If I do more work than what's available, right? Initially, your batteries, sure, you can submit it to a load and test how much potential energy is in the batteries.
Yeah.
But
So
So
you are
with
going to
like
measure the amount of energy that battery number one is providing to the system or not?
yeah, sure, you can measure both battery banks, right? Battery one, bank number one, battery bank number two. That's your total potential energy available in the system. And then if you do more work than that potential energy, and there's still energy in the batteries and it's self-running, that's just like doubling up on your confirmation that it's over unity. That would be
Yeah.
larger over unity.
But what kind
so
of work are you using to make?
Um, we're gonna put the gen coils to supercapacitors, and then my electronics buddy there, Joe, he's gonna design it so it's recording the actual work done to the load, and it has a minimum threshold in order to power the load, so you know that it's doing a minimum amount of
But
work.
the load is powered by what kind of source? What is the source of the power?
The rotor, the magnets spinning on the rotor are going to hit. There's going to be generator coils on the machine as well. So some of the coils will generate electricity from the rotor, from the magnets going by.
So you are using a different design compared to Bedini, because Bedini,
Uh, kind
you
of.
know,
They advanced Bedinis. They started putting gen coils on them as well. But I
yeah,
mean,
yeah. If I remember well, in this paper, there is three coils. One for kind of excitation, one is for the
yeah,
feedback to the transistor, and one is collecting excess of energy. So you are using a coil, and you are
yeah.
charging a supercapacitor. Why are you using a supercapacitor?
Just because it evens out the. It evens. I don't want to put it into the battery. I just want to do a run a load with it. So I mean, you could put it into a battery if you wanted to, but this is conventional electricity we're generating, so you don't need to have that same. It's not a spiked flyback voltage. So I feel like capacitors are a nice way to collect it and then discharge it into a load.
Okay, so you are charging the capacitor and then discharging
Power.
after a certain amount of time. You will discharge,
We're just put it into caps, and then yeah, pull a constant load from those caps.
but just remember you that when you charge a capacitor or a supercapacitor, you are wasting a small amount of energy inside the
Sure.
equivalent serial resistor of the supercapacitor. It's uh,
Yeah, I agree.
it's easy to measure. You will lose a small amount of energy. Why are not? Are you? Why don't you
Same thing
use?
if you put it in a battery.
Yeah, yeah. Your coil, which is producing this voltage, can be connected to a resistive load, and you can measure voltage and current
Well,
inside
for
the
its
electrode. No,
purpose, no, because we want to use that flyback voltage for the vacuum energy inside the battery's chemistry. So that's a separate system, separate source of energy. The vacuum energy coming into the charge battery is just totally separate, and we'll keep that in the system. And I mean, we're going to have to figure it out and see how much excess energy is available. Maybe there is enough excess energy from battery number 2 that we can just harvest directly
yeah,
from it.
this is the idea of Bedini, that there is excess of energy inside the battery. I disagree with your explanations about dipole, because I know a little bit about dipole. I'm afraid that dipole will not be accelerated inside the battery. For me, it's a magic system. If you increase the energy inside the battery just by using pulses of high voltage. The only thing I know about lead battery is if you use high voltage pulses, you will desulfate the electrode, so you
Correct.
will improve the you will reduce the internal resistor of the battery, so you will gain a small amount of energy. Tesla explained this clearly, that he have designed high pulses, high voltage pulses, in order to improve the quality of the battery. But there is no excess of energy. It's only a way to destroy sulfate on the, on the electrode. It's
Well, I guess
pure.
it depends on the speed at which you pulse it.
Yeah, yeah. I
Faster
take a
and
look
larger
at the
spikes.
papers, and it seems that you have to go up to megahertz, something like a few megahertz, in order to destroy this famous crystal. I don't know if people are using nanosecond pulses. Uh, I just want to remember you, because I teach electrochemistry, that the
I mean,
exchange of classical electron inside the electrolyte is a slow process. You cannot exchange electrons with a speed of 1 nanosecond inside the battery. I don't know what kind of process you are going to do with.
well, that's where that dipole comes in, because we're not using conventional electricity, right? We're raising the energy of the conventional electricity and the ions. The electrons and the ions have energy added to them from the vacuum, which is a completely different source. It's
I disagree.
integrated from the vacuum.
I
Well,
completely disagree.
that's why
In
we're
a
playing.
battery,
That's
you
why.
have ions, only ions. Electrons are just exchanged at the surface of the electrode. There is no free electron inside the battery. And the dipole for me is water, because water has a very high constant of dipole moment. So there is millions, hundreds of millions of dipole inside the battery, because we are using sulfuric acid, which is
Yeah, I
water.
agree.
So there are dipole, but you cannot accelerate dipole. I completely disagree. You cannot accelerate dipole with high speed pulses. A dipole are associated with water, and we know the velocity of the water inside the ion with
Yeah,
the
but when
ions.
you put there's different flows, right? When you slam those electrons into the plates, they're much higher, faster moving charge to mass ratios than the ions, right? So you get an
But
instantaneous
no,
dipole.
no, I
So
disagree. I disagree. When
the flow. Well,
you
I guess this is why
when you
applied
make
science is nice.
electrochemistry, you have one electrode, and you change the potential of this electrode compared to the electrolyte. So you give energy to electrons. Electron will jump or came from ions, and after, electrons are not freely moving inside the liquid.
No,
I
but it's
disagree
before. It's
completely.
before.
No, no,
It's that
no,
instantaneous before. That's where they're freely moving, right? It's that flyback spike prior to the balancing of the charge,
no.
right? The charge flows there. And again, this
I
is the
don't
explanation
agree.
that Tom Bearden uses, and this is why debating and math and equations is one thing, but actually building and testing is another. So we're going to find out very soon if there is excess energy, and then the debates can go on about where it's coming from.
I'm thinking you are fairly honest by making the experiment and making measurements, but I have seen a lot of people trying to confuse about explanation about block wall of magnetism, about wrong way to measure the energy. So I think you are clearly honest and try to make a good job, but you have to take care about the way you are measuring the energy in the battery number 2. This is the main problem for me, because I saw a lot of tricks. For example, in my design, I can show you my design, which is just to demonstrate that the energy from a charge coil by a current can be captured in a load just after switching off the coil. And if you just use, like me, an oscilloscope and measure voltage current, the product is the current, you get 100% of efficiency at maximum. But for example, I try to simulate on RMS measurements, and you get 200%, 400%. You get whatever you want just by changing the method. So,
no, I agree. It's the same as measuring reactive and non-reactive power and coming to conclusions.
No. It's not a problem of reactive, of non-reactive.
No,
If
but you
you
can have, if
measure
something's out of
voltage and
phase,
current, you
I know,
are sure
but there's
that
been
you
other
will have
devices.
the energy dissipate on the load. My load is always
on a load. Yeah, I agree.
So I don't want to use other load than a resistor. So I can compute voltage, current over time, record on my oscilloscope, go back to the computer and make the integration. And I found what is predictable.
I agree. We need to measure the total work done. Eventually, if we get enough work, then it's definitive proof that we've gone over unity. There's a threshold at which enough work is done.
With a coil, there is no way to get over unity. No problem. I just make the measurement.
You say that, but I know of Thane Hines, who has a company called Regenerex, and he's getting over unity and has patents around it out of Ontario. It's not a Bedini system, but he's got similar technology, and he uses just coils. He's not doing it in the battery, and he's negating all negative work and only doing positive work, and he's written a lot of papers on it. Are you aware of Thane?
No. If you can send me references, I will take a look. He's using just a coil?
Just coils. He just does coils, and he recharges his batteries. He's got all the videos, and he's got a company built around it and a lot of money going into it. I've spoken to him for several hours, and he's basically also rewritten a lot of the theory and shown that you can produce excess energy just within the coils, both excess kinetic and electric.
Just by switching on and off a coil, you can produce more energy.
Not straight just switching. He's got a little bit of technique in there. I can send you all the stuff. It's interesting.
Okay, so this guy,
I agree. Like the flyback you get from a quick call, the flyback you get is not over unity. I agree. The flyback you get is not over unity, but
it's not over unity. Okay, so because the guys that pretend to make over unity using coil and MOSFET, as I explained to Chris, you are telling that 1,000 or 10,000 of engineers working.
Yeah, I agree. I agree. I heard that. I agree. It's the whole thing, right? It's not an individual component.
Try to gain 2% of efficiency, and Bedini 10% of excess energy. So we are all stupid guys.
I agree.
We don't understand.
It's like saying
in the coil. I disagree.
I agree. No, I agree. And it's like saying a pulse motor on its own is not over unity. I mean, a pulse motor converts mechanical or electrical to mechanical energy at 40 to 60% efficiency. So individual pieces are not over unity.
Spencer, I have a question.
I agree with you. I can send you my setup and my simulation and my experiments. Is here.
I will get
Perhaps you can
Spencer.
see here. It's not easy to
I
see.
think he can't hear me.
I can hear you. Yeah.
It's
My question. Let
it's just a switch, a MOSFET that switch on the coil with
Yeah.
a certain amount of current, and then another MOSFETs which switch off the the coil and switch on a resistor and make measurements of the energy that I can capture in this load just after charging the coil with a certain amount of current, and I make all
Yeah.
the measurements. And
Dr. Elie. Dr. Elie.
actually, the yield is
Wobb's just trying to talk to you, Dr. Elie. Wobb's just trying to talk to you.
Oh,
Can you
I
hear
was
me?
saying, I am talking to you. Sponsor, I had a
Oh, okay.
question to you. I think Dr. Elie can't hear me. So my question is, like from your system, the energy that you
Yeah.
capture, is
Yeah.
it like from the primary battery or is it from an external now, a different external source? Or is it from like the primary battery? The energy that is going
The excess energy we're saying we're capturing is coming into the system from the vacuum or radiant energy or whatever you want to call it, but it's because of the high voltage spikes going into the battery and that whole system. Exactly what is causing it? I mean, I lean toward Tom Bearden's explanation. Dr. Elie doesn't agree. It could be wrong, but overall, I've seen these systems and there's been lots of different types of motors that I've seen that do
yeah.
run perpetually and produce excess energy. So we're going to find out. Like I say, we can talk about the theory once it's working. That's why applied science is my favorite, right? Talk is one thing, but applied
yeah.
science isn't.
I can agree that in the vacuum that demonstrated by Casimir effect, by I don't know exactly why, but you can have a force which is not the same as energy. Nobody's actually there are some experiments measuring with high precision the Casimir effect, which is a vacuum. You have two plates of metal inside a vacuum, and you can measure the force that grab one plate to the other, a very
Yeah.
small, very small, very small, depending on the size. Okay, you have to design a micrometer or nanometer distance between the plates. As long as you are using a macro system, there is no more force that you are going to have in your system. So, I I'm sorry to disagree, but it's not a problem, as long as we kept correct. I, I disagree that you are flying the dipole inside the battery because of high voltage pulse. I will be pleased.
Well, I guess Dr. Elie, if we get excess energy here in the next couple of months, you're going to have to figure it out for us.
I hope that I will
Yeah.
follow your channel
Amazing.
every.
Thank
So
you. You guys,
there's
I
a
do have to get going. I've got to get going. I'm sorry. I enjoyed this and I appreciate this, but I do have to get going for today.
Okay, thank
before you
you.
go, there's a guy
Yeah.
called IT was asking if you can show proof. But also, let me. How can I send you my email so that you can reach out? I can reach out and share
My
my.
email is on my channel. All my contact info is on my channel. It's spencer@limitlesspotential.tech.
I
And
see.
then my phone number's on there, all the contact info. Yeah, I read every single comment. And yeah, to the guy who's asking if we can show proof, we can once it's working. That's the whole point of this particular endeavor, is to do it properly and scientifically and definitively.
What
Okay,
about
thank you.
this this first one which you showed? Is it working yet or still not yet? There's a first one which you showed on the
The little
slide.
one, that's just the regular Bedini motor. I do plan on taking some measurements there and doing a couple little upgrades. We're going to put some south pole magnets on there and just see the difference. Again, those ones, they're not self-running. If they do excess work, you can
I,
measure that they do excess work
I
sometimes, but it's
cannot
not
hear
self-running.
you.
I do have to run though,
The
gentlemen. I
same
appreciate your
problem.
time and I look forward to the future here.
Down.
It's okay. It's okay.
Scam,
Thanks a lot.
Scam Chan. Oh, Scam Chan. Yeah,
Yes,
chasing it. He
Captain.
sounds he sounds like a very positive guy.
Yes, Captain
If it
was
doesn't work,
asking.
if it doesn't
He,
work as a smaller version, yeah, well, you got to step it up. You need the higher voltages. You need the big battery bank. So sure, you can make the rotor smaller, but there's a certain threshold of voltage that you need in order to get these effects.
You
So
are on stage, but
yeah.
I cannot
Anyways, I
hear
appreciate your
you.
time, guys. Talk to you soon.
I have to
okay. Okay.
disconnect.
Thanks a lot. Coming around. You can't hear anymore again. Let me send you